Alright, so in this problem we are given an integer array called prices. Now each element in this array represents the price of a given stock on that particular day. Now our task is to figure out the maximum profit we can make by choosing just one day to buy the stock and another future day to sell it. And the important restriction over here is that we can make only one such transaction, that is one buy and one sell. And if the prices just keep decreasing, right, and there is no profit possible at all, we simply return 0 as our answer. So for example, if the input array is this, the best option is to buy at price 1 over here, right, and sell at price 6, which gives us a total profit of 5. And that is going to be the maximum profit possible through any transaction if you see. So how do we solve this efficiently? Let's maybe now understand the approach over here. So what we essentially need to do over here is to buy on the day when the price is minimum and sell on a future day when the price is higher than this buying price. Now there can be several such transactions if you see that could be possible, right? But we need to find out the transaction that gives us the maximum profit. So what we do is we simply traverse the input array, looping over every element which represents the price on that particular day from the left to the right, right? And while doing that, we will maintain two variables: min price, which keeps track of the lowest price we have seen so far, and max profit, which keeps track of the highest profit we have achieved. Now at each step while traversing this array, if the current day's price is lower than our minimum price, we will simply update the min price and buy on this day. Otherwise, if the current price is greater than the min price, we will compute the profit by selling at today's price, which is current price minus min price. And if this profit is better than the maximum profit that we have seen so far, we will just update max profit value, right? And then we will move to the next element. So this way, by the time we finish the array, max profit will contain the best possible answer. So now maybe let's see this step by step using our example. So this is our input array, right? The input price array. Now on day 1, price is 7. So min price becomes 7 itself and the profit is 0. On day 2, price is 1, which is lower than the current min price. So min price becomes 1 and profit is still 0 because we have still not been able to sell the stock, right? On day 3, price is 5, which is more than the min price. And so now we will compute the profit on this particular day, which is going to be 5 minus 1, that is equal to 4. And so the maximum profit that we have seen so far becomes 4. Now on day 4, price is 3, which is again greater than the min price. So we calculate the profit, which is equal to 3 minus 1, which is 2. And this is now less than the maximum profit that we already have. So there is going to be no update. Now on day 5, price is 6. So profit by selling on this particular day becomes 6 minus 1, which is equal to 5. So we just update the max profit to 5 now. Now on day 6, price is 4. So profit becomes 4 minus 1, which is equal to 3, which is smaller than 5. So there is no change again. Now at the end of the array, finally the best profit we can make is 5. And that is going to be our final output. Right? So that's the entire solution. I hope you understood it well. Now let's see the code for this. So first of all, we define the function max profit that takes the list of prices as input and will return the maximum possible profit from a single transaction as the output. Now we initialize min price as infinity, since before seeing any prices, we assume the lowest price is infinitely high, right? Then we initialize max profit as 0 because initially no profit can be made. Now we start looping through each price in the array and we check if the current price is lower than the min price. If yes, we simply update the min price to the current price. Now we check if the profit from selling at the current price exceeds the best profit so far or not. If that's the case, we update the max profit, right? And finally, we return the best profit after the loop is done. And that is going to be our final output. So that's the entire code for this particular solution. Now talking about the efficiency, the time complexity over here will be order of n because we only go through the array once, right? And the space complexity is order of 1. It is constant since we are just keeping track of two variables, which is min price and max profit. So that's it for this particular problem. I hope you understood it very well now, and now I will see you in the next one. Happy coding.